Hello everyone, today we'll talk about the problem continuous subarray sum. We're given an array of integers, and you have to say if it's possible to select a subarray of that array that consists at least of two elements, and the sum of those elements is divisible by k. So in other words, we have to find the contiguous part of the array, so remove some elements maybe from the beginning, maybe from the end, and be left with a contiguous part, such that the sum is a multiple of the given number k. Whenever you see a problem about contiguous subarrays that you don't know immediately how to solve, there are two main ideas that it's a good idea to think about. First one would be to use either a sliding window or a two-pointer technique, where you can modify when you are looking at a certain subarray. So you have a certain subarray. When you can modify the thing you're looking at, the property that you're looking at, easily by adding an element here, or removing an element here. If you can do that, so you can push the bounds and modify the result easily, and also if you're able to tell whether or not you should move the right end or move the left end, then you can solve the problem in linear time, because both the left and right end will always be going to the right. So that would be linear time. So this is one method for problems where you are thinking about contiguous subarrays. But there is another method which we would like to use in this problem. And that method is to have a subarray of a given array, and we want to think about it as a prefix of the array minus a smaller prefix of the array. So this long prefix minus the small prefix is exactly this. So there is only one way to represent a subarray as a difference between two prefixes, and there's only a linear number of prefixes. However, what we need here is for our property to be, in a way, subtractable, because we have to calculate the property for the long prefix and subtract something for the short prefix to be left with the result for our subarray. But in this problem, it turns out that it's actually quite easy. So let's think about how we can represent our problem in terms of those prefixes. We want our subarray to be equal to 0 modulo k. So what do we know about those prefixes? Of course, if both those prefixes also have the sum divisible by k, then our subarray is good. In fact, even the first prefix would be a good subarray. But that's not the only way in which our subarray can have a sum equal to 0. In fact, what we need is that if the large prefix modulo k is equal to some a, then what should this smaller prefix, the sum of the smaller prefix, what should its remainder while dividing by k be? So that this part will have 0. Well, if this part has, this large part has remainder a, we want this small part to have remainder 0, then the previous remainder, well, it is still k, it's still a. So modulo k, it's still a. In other words, whenever we see two prefixes that have the same remainder modulo k, then this subarray that is defined as their difference will have the remainder equal to 0. So we've almost solved the problem. We're only left now with the case where the length has to be equal to at least 2, but that just means that we have to make sure that we never look, when we look at a given prefix, so the large prefix, we do not look at the prefix that's one shorter than it. When we look at the prefix that's two longer than the one that we want to look at. So we have to have a lag of one step when remembering what we've seen before. But the solution here is just to, as I've mentioned, remember all the possible remainders we've seen before, remainder the current sum of the prefix, and we update the sum on the prefix. And now, if we have already seen that sum, that means there is a shorter prefix that has the same sum. So this is a subarray that has remainder equal to 0. The same sum, I mean the same remainder while dividing by k. So we can return true. And then we of course have to add the sum that we've seen to the set of seen sums. And now if we were to just add the sum that we've currently calculated, then this would include subarrays of length 1. So you have to remember both the sum and the previous sum. and when we add the previous sum, and then we remember our current sum as the previous sum. And of course, if we haven't found this matching pair, then we can return false, and that's it.